In this video, we want to share how MID architects managed to construct buildings that seem completely impossible, especially in the cloudscape of Haiku and Chaoyang Park Plaza projects. Although their forms appear very free, almost like sculptures, behind them lies an extremely technical and precise construction process. I'll start with cloudscape of Haiku. This building is made almost entirely of reinforced concrete, but not just any concrete. It's monolithic exposed concrete designed to maintain the same texture and color across the entire surface. The building shape is so curved and irregular that it cannot be built with standard formwork. Therefore, from the design phase, a digital parametric model was created, where architects, structural engineers, and building services teams worked simultaneously. Every curve, every thickness, and every opening was defined before construction began. The formwork was the most difficult part. Each section had to be custom made, guided by the digital model. The internal structure uses double-layered waffle slabs, which allow for the creation of enormous cantilevers and at the same time conceal all the ducts, cables, and ventilation within the concrete. Nothing is visible. After pouring, the concrete finish was carefully crafted to eliminate any visible joints or color variations, achieving the building's distinctive carved cloth appearance. The second project is Chaoyang Park Plaza, a massive complex of towers in Beijing. Here, the concept is based on the Shanshu landscape, which is why the towers resemble mountains and the lower buildings look like eroded rocks. Although they appear organic, they actually have a highly technical hybrid structural system, a reinforced concrete and steel top core that resists lateral loads, but with columns and beams that curve to follow the building's shape. The facade is one of the most impressive achievements of this project. More than 50% of it features double curvature, something that is typically extremely expensive or nearly impossible. To make it feasible, the consultants used an algorithm that streamlined the surface into manufactural segments. Then, the laminated glass panels were cold bent directly into the factory, fitting them with millimeter precision to the aluminum frame. No two pieces are alike. They were all CNC cut and they were assembled following a 3D beam model. In both projects, MID Architects demonstrates that materials like primary reinforced concrete, steel, tinted glass, and formwork systems can cease to be rigid and become fluid forms when combined with digital technology and interdisciplinary coordination. As a student, what we are impressed more about is how such an organic form can only be built when engineering and architecture work together from day one. This project helped us grow because it confronted us with real design and construction errors. One of the most important lessons was the need to always verify scales. Our formwork was initially out of proportion, and we had to correct the wooden timbers, beams, and braces so the model would work like a real system. We also learned not to rely on the first idea since our original concept wasn't structurally viable. We reorganized it and turned the chessboard into a modular system that could actually stand. Another major improvement was researching each construction element in depth. Understanding the role of bracing beams, panels, or armatures completely changes the way we build the model. Using simulation materials like balsa and craft paper also taught us how to represent real construction logic. Overall, this process made us more careful, more technical, and more aware of how architecture and engineering come together. It taught us to confirm scales, research materials, review installations early, and not to be afraid to correct mistakes. We are very sure these lessons will guide us in future projects.